Hello everybody, welcome back. Today I'm going to show you how to make great drawer organizers for your tools using a computerized milling machine. This is going to be a long video, a tutorial style video that goes through each step in depth and walks you through the process of the software, the hardware, and cutting the parts on a machine. The first step is to get your tools, lay them out in an area that's the same size as your drawer, take out your phone, and take a picture of them in the format that you'd like. After that, you're going to take a tool, and if your tool happens to be larger than a piece of paper, you're going to tape two pieces of paper together, preferably using something like blue painter's tape, and you're going to get a pattern marker, a long skinny stem marker, and you're going to make two marks on the piece of paper in an area that's exposed. You're going to put the tool on the piece of paper and then use the marker to carefully trace around the perimeter of the tool, creating an outline of the tool. You'll repeat this process for every tool that you have, and then we're going to use a scanner to scan the tools into our computer. For larger tools, you'll separate this piece of paper and scan each piece of paper individually, and then we'll combine them together in an image software. All right, so we're on the computer now, and the next step is to scan all of the papers and outlines in. So we put one of these into the scanner. We bring up our scanning software. We can do black and white or grayscale, and the resolution, I'm going to use 150 dpi. It doesn't really matter as long as you're consistent. And then give the tool a name. So drill extension for this one, and then scan that in. So here is the scan. That's perfectly fine. We're going to repeat this for every tool that we have done. For ones that were separated into multiple pages, we're going to do each page separately. All right, well, we have finished scanning all of our tools, and I've organized all the scans into a folder. And what we're going to do is now retouch these using Adobe Photoshop so that we can convert them to good quality vector graphics. We're going to start with the most difficult one, which is the tools that were separated into more than one page. If you only have tools that fit on one page, this process will be a bit simpler. So we're going to open these two images in Adobe Photoshop. There's the first one, there's the second one, and as you can see, they're both in the same orientation, but one needs to be flipped over. So this one, I'm going to rotate image rotation 180. And in the first one, we're going to combine the two images into one and use these little black marks we made to line the two pieces of paper up. So the first thing we're going to do is make this canvas larger. So we'll go to Image, Canvas Size, and increase the height here to something like 16 inches. And then we'll double click on the background layer and rename it Layer 0 so the lock goes away. And then select the Move tool, and we'll move this part of the image all the way to the top. And then we'll go into the other image, select all, copy, and then paste that into the other image and move it down to the bottom. And now between the two images, you can see we have this extra space. So we need to delete that. So we'll grab the marquee tool on the bottom layer here, the layer for the bottom of the tool, and we'll select everything above those two marks. Okay, you can see the image isn't perfectly aligned, so we'll leave a little leeway there. We'll delete that, and then on the other layer, we will do the same thing, where we delete everything below those two marks. And then we are going to move these two together. So just drag them close to each other. And then we can use our arrow keys to carefully align these. And you can see the bottom image needs to rotate a little bit to line up properly. So what we're going to do here is on that layer, we are going to do Command T for transform, and we're going to just slightly rotate this just so it lines up a little better. Those two marks, and then move them over. Now what we're going to do is we are going to combine these two layers so we can work on one layer. So we select both layers in the layer panel, and we go to Layer, Merge Layers. Now we're going to clean up the outline here. You can see I made a lot of errors, so we're going to grab the brush tool and make sure that the size of the brush is similar to the size of our marker. And then where there's gaps, we're just going to close them together. And we're not really worried about anything on the inside of the tool. We're just worried about the outline that goes around the tool. So we're cleaning up, just by a little bit of drawing here, we're cleaning up the exterior outline around the tool. So anywhere there's little sharp edges like that, we just kind of smooth them out. You do not need to be too particular, and we just kind of go around the whole tool and look for any gaps or any really thin areas, or any areas that have really tiny features that aren't necessary. And that should do it. Now we are going to clean this up to make a silhouette image. So we want to first start by deleting any of the extraneous marks. So we'll grab the marquee tool, we'll drag around these tape and line up marks, and we will delete them. And now we're going to use the magic wand tool to select all the area around the tool. So the magic wand tool selects similar colors. So if we click out here in the white space, it's going to select according to this tolerance. So it's going to select white that is up to 10 shades whiter or brighter, or 10 shades darker. So if we click here, it'll select everything around the tool as long as we have this contiguous checkbox clicked. So we'll click that and we get a nice selection of everything around the tool. So we've selected the white space around the tool. We now want to invert that selection, so we're selecting just the tool. So we go to Select, Inverse, and now the tool is selected. And what we do now is we do Select, Modify, and Smooth. That'll get rid of any harsh little imperfections. A radius of 5 is pretty good. Hit OK. And then we're going to do Edit, Fill with black, and that should fill the tool in. And then we'll deselect this. And now we have some other areas that were selected, so we're going to clean them up. So we'll grab the marquee tool around this area. We can add to that selection by holding the Shift key, and we'll just keep adding these extraneous areas that we don't want as part of the selection. And then we'll do Edit, Fill, and we'll fill those with white. And then we can deselect again. And now, since we have a nice black silhouette for the tool, we can again use the magic wand tool to select the tool itself. And now we just have the tool selected, so if we do Select, Inverse, we'll now select everything outside the tool. And then we can do Edit, Fill with white. And now we have our prepared image. So this is the image we're going to convert into a vector, and we're going to use that to drive our tool paths. So to do this here, now we're just going to save it. So we're going to save as, and we'll save it as saw. I'm going to put it in my retouched folder. And then I'm going to do File, Export, Export As, and then I'm going to save it as a JPEG. anything above good is high quality enough for what we're gonna do. So we'll now click export. That will give us a JPEG image of this. And then we're going to use these images to generate vector files. So now you repeat this process for every tool that you scanned in, and then I will show you how to convert these to vector files. All right, so we have finished retouching all of the photos and exporting them as JPEG images. Now what we're going to do is convert them to vector images. So we are going to use this website called Convertico, which is a file converter. It's a pretty good site because it's free for a couple files unless you're doing a ton of them. So you choose the file that you want to upload, which is going to be one of our retouched JPEG images, like for example, this oscillating tool. We hit upload, and then we say what we're going to convert it to. So we want to convert it to a vector. Right now we're going to use Adobe Illustrator, so AI, and then we hit convert. Wait for it to convert. And then we download the converted file. So we repeat that for every tool. All right, well now we have converted all of our raster images to vector images, and we have them all here in Illustrator format. And we're going to refer to the image we took earlier of the drawer. So we're going to open up Adobe Illustrator, create a new document, and we want this to be in inches and the size of our drawer. So for my drawer, that's 19.375, and the height is 21.5. We hit create. This gives us a blank working canvas. I'm gonna hit Control R to turn on the rulers. And then we are going to open those other files. So we're gonna open up, for example, the drill. And there it is. And then we're going to copy that and paste it into our other file. Now, once you bring this in, it may not be at the correct scale. And as you can see that this scale is much larger than the area of the drawer. So we have to scale this so it is the correct size. And this is based on pixel dots per inch and resolution. So if you scanned at 150 dpi, you're going to click this image and go to Object, Transform, Scale, and then you're going to scale this by 48%. Now, if you're wondering how I got that scale, most image converters convert based on an original image of 72 dpi, and we scanned our images at 150 dpi. So basically, 72 dpi divided by 150 equals 0.48. So in other words, our images are 48% larger than we want them to be. So we need to scale them by 0.48. So whatever you scanned your images at, you will divide 72 divided by that number, and that gives you your scale factor in percentage. So you bring every image in and scale them to the correct size, and you can check these measurements with a ruler. Okay, so now we have all of our tools outlines in Adobe Illustrator, and we're going to start arranging them so that they look like our plan. So this is what our plan looks like. We're going to start arranging these tools so they look like that. So once we have these arranged now, we may want to add things like pickup points. And we can do that simply with the rounded rectangle tool. So areas where we might grab, we can put a large spot over this. Keep in mind you might want to grab these things with gloves on, so be fairly generous in the grab point size. Okay, so now that we have things looking the way we want, we need to simplify the shapes a little bit. If we were to go into all these shapes, we would notice they have tons of little vertices, trying to get every little nook and cranny of the image that we had before. So the way we can do this is with the simplify command. So we click on the tool. We don't need to worry about the pocket for grabbing, just the tool. And then we go to Object Path Simplify. And this little button here means auto simplify. If you click more options here, you can see it started with 94 points and it's going to reduce it down to 73 points, and that's going to make a big difference. Now you can play with these and see what the resulting looks like, the resulting tool that'll update in real time. It's okay, we want to get the point count down pretty low, but we still want to retain the basic shape of the tool. So you can play around with that, see how the tool looks as you reduce this. The fewer points we can get, the better, and do this for every tool. Okay, now that we have simplified all of those, we are going to combine them into single shapes. So we'll click the pocket where we are going to have a finger pocket, and then shift click the tool, and then go to Window, Pathfinder, which will bring up the Pathfinder window. And you're going to click this Unite button, which will take those two shapes and convert them into one. And we repeat that for every tool. Now we want to take this image and we want to export it into a file format that our CAD software can understand. For us, that is going to be a .svg. So we'll go to File, Export, Export As, and we're going to give it a file type of SVG, and we'll call it drawerplan.svg. Hit Export. And hit OK. All right, now we are in Fusion360 and we have created a new design, and we want to make sure we are in the design workspace here. And the first thing we're going to do is go into document settings and make sure our units are in inches. And then we are going to click the new create sketch button, and we're going to sketch on the top plane. So I'm going to click there. So we're looking down on the top and click on the top plane. And we're going to grab the rectangle tool, starting at the origin here, and we're going to drag out a rectangle. And then we're going to press the D key for dimension, click on this top here, and enter the width of our drawer once we click. So for me, that is 19.375 inches. And the height of the drawer for me is 21.5 inches. So this gives us the outline of the foam. So now we click Finish Sketch, and we can rotate around so we see that. And the top is up here, and what we want to do is create a 3D solid from this. So we're going to click this Extrude button, and we want the top of our surface to be thickness of the foam. So for this foam, it is 2.24 inches thick, the ones I'm using. It's 57 millimeters thick. So we're going to extrude that one-sided for 2.24 inches with a 0 taper angle. And that is going to give us a solid that looks like our block of foam. So now we're going to click this top surface and again click Create Sketch. It's going to let us put a sketch that resides on that top surface. Then we go to Insert, Insert SVG, and select that file that we exported from Adobe Illustrator. And then we'll may have to do some manipulation to it. So it looks like for our purposes, it's upside down. So we'll rotate it by 180. We're going to move it off of the part. And then SVGs typically come in at the wrong scale in Fusion, not quite sure why. But to fix that, we scale up by 33%, so 1.33, and then we hit OK. So there are our outlines. Now we want to, this is an SVG, they are uneditable. We can't really do anything with these. So in case we need to make any adjustments, we are going to highlight all of these and copy them by hitting Control-C, and then paste with Control-V. It could take a moment for your computer to do this. Just watch the progress bar down below. And then you'll get this little crosshairs, and we'll move that over onto our part, which will be right here. Hit return to accept that. So then we'll come over here and highlight all the entities that came in with the SVG and hit delete. And then we'll press finish sketch. So now what we have is those entities residing on the top of the part. So what we're going to do again is click the extrude button, and under profiles here we should normally have that selected. We'll click each pocket for each tool, and then you'll notice we get this little arrow. So we want to drag that downward, the opposite, probably the opposite direction of the arrow, into the part. And this foam has layers of 1/8 of an inch. So we want to cut in full layer depth. So I don't want to cut all the way through the foam. I want to leave about a 1/2 inch on the bottom of the foam. Excuse me, about a 1/4 inch. So I'm going to make this number -2 and click OK. And you'll notice now we have the model of what we are going to make out of the foam. So this is a good point to save. File, save. I'll call this drawer 3. It's the drawer I'm doing, the third one. And click save. And now we're going to jump over into the manufacture environment in Fusion 360. So up here, click on design and bring this down to manufacture. Okay, so we're in the manufacture workspace here, and the first thing we have to do is create a new setup. And in the setup, there's a lot to pay attention to, but we basically need to make sure we have a milling operation, and we need to pick a point that we're going to start, that we're going to use as our reference point. This is called the work coordinate system. So when we jump over to the actual machine later, we're going to have to identify this location on the part so the machine can cut from that location. So we're going to use this lower left-hand corner on the top of the part. So we click there and we make sure our axes make sense. So this direction on the part will be the x-axis on our machine, this direction will be the y, and this direction will be the z. Then we jump over to the next tab, and this is stock. So this is the size of the part that we're going to cut this part out of. So the size of the material. So we're going to use relative size box, and we're just going to zero all these out because we're starting with a part that is the same size as the part we're going to end up with. All we're doing is cutting these cavities. So we click OK, and now we have a new setup. So once we have the setup, now we need to add tools to our project. So we're going to click on the tool library up here, and we may not have any tool. So we can go in our documents here into setup 1, and then click plus here. And we're going to add a flat end mill. And the one I'm going to be using is an Amana tool, A-M-A-N-A. It's a 1/4 inch diameter tool. It's a down cut, 2 flute, and it's designed for foam. And I will put a link to this tool in the description of the video. You can use any cutter really for foam, but it has to be exceptionally sharp because foam moves out of the way when you try to cut it. So very, very sharp is a prerequisite for this. So we describe the tool that we're using now. So this particular tool is a flat end mill. It's in inches. It rotates clockwise. It's got 2 flutes. This particular one's made of carbide. And then we describe the tool down here. So the diameter of this tool is 0.25. The shaft diameter is the same as the tool diameter. And the overall length of this particular tool is 3.5 inches. And it sticks out below the lowest point on the spindle. It sticks out about 2.6 inches. And almost all of that is just almost all the way up to that is shoulder length on the tool. And then the actual flute length, the actual cutting length is 2.5 inches. So now that we've described the tool, we hit accept. this becomes our tool number 1, and for this project that's the only tool that we need. So we'll close this out. So the next thing we do is we want to add an operation, and the first thing we're going to do is we're going to cut the perimeter of every one of these pockets out. That seems to work best in foam. So we'll go up to these 2D operations and we'll add a 2D contour operation. We don't have coolant, so we're going to disable it. We're going to pick the tool. There's only one, so we're going to pick our 1/4 inch end mill. And then we're going to run basically as fast as our machine can run. So for the machine I'm using, that's 18,000 RPM. And we're going to cut at 210 inches per minute. And then under the geometry tab, we're going to select the contours. Now we can select the top contour of every one of these pockets. And then move over to the heights tab. When I do this, it's always pretty useful to look at the side of the part. So I always like to set these to model top. And this is foam, so all of our clearance heights are above the foam, so we're okay. These are all positive and above the foam, so that's good for us. The bottom height is how far down we're going to machine, so we're going to change this away from selected contours to selection, and then we're going to come in here and select a point on the model that is at the depth that we're going to cut to. So any feature will do. And then we move over to the passes tab. And in here, there's a few things we want to change. The first is we don't need a tolerance that fine for foam, so we can shorten this tolerance up quite a bit. That'll generate a much smoother tool path, and in foam it won't matter. We want to change the compensation to right because we want to do conventional milling for this particular operation. Compensation is going to be in computer. And then we want to cut at multiple depths. Now you can experiment with how deep each one of these cuts can be, but with this particular tool, 0.375 has worked very well. So now we go over to linking, and it may tell us that the safe distance is larger than our feed height, so we're going to reduce this down to 0.1, which should clear that error. And then we'll click OK. And now we generate the toolpath. And you can see that we have toolpaths now for each one of those pockets that's going to cut the perimeter. Now we are going to add another toolpath, a 2D adaptive path, to clear out the middle of those pockets. So we come in here, we select our tool, which in this case is already selected. We make sure coolant is disabled, and it should have picked up the feed rates from the previous tool. Some things we might be able to change here. We might be able to up the ramp feed rate to 150. Then we go into geometry, and we're going to select the pockets. And then we go back to heights and do the same thing we did last time. So model top, model top, model top. And then the bottom height, again, we're going to do selection and pick a point at the bottom of our pockets. Then we go over to passes. And again, we can lower the tolerance. We don't really care in this case. Our optimal load can be increased. We want to cut with most of the tool because it's foam and we can do that. So it's a 1/4 inch tool. We're going to go cut with almost a 1/4 inch of it. We're going to do multiple depths. I think we can get away with a 1/2 inch for each depth of cut. We don't need to leave any stock on there. And under feed optimization, you can leave those settings as they are now. Then we just look in here. We don't need to helix. We can just plunge into the part, so we don't need to gradually enter the foam as you would if this was a metal or something. And that should be good. Click OK. And then click on the operation and generate. And you'll see now we get these tool paths in every pocket. This may take a little bit of time for your machine to generate it. Okay, so there are the tool paths. And now we can click on this setup here and go to simulate, and we can see what's going to happen here. So defaults should be okay. We'll run it. It's going to show us what we're going to cut. And that looks good to me. So the next step is going to be to post-process this code. So to do that, you need to make sure you have a post-processor for your machine. So you can go to Google or any search engine and type Fusion360 post library. And that'll give you a result here, and here you just search for the machines that you have, and Autodesk has a lot of a ton of posts for this. So you download the post processor and then you load it in. I already have that for my machine. So what we do is we click on the setup here, setup 1, and we do post process. And in here we select the post. So I'm choosing from my library. So I have this Techno CNC post. This is the one I'm going to use. That's the machine we're going to cut it on. I select that. I give it a program number. 1001 is fine for me. And then the output folder here is where we're going to put it. So I'm going to put that on my desktop. So select here, desktop. Extension is .nc, and you will want to look through these settings to make sure that they make sense for your machine. The only thing I can tell you is that if this is your first time using the post processor with your machine, you should watch the machine cut exceptionally carefully. Then we click post, save. And this is the file that it generated. So we take this file, and for this particular machine, we put it on a USB stick, and we insert it into the machine. And I'll see you guys in a second over at the machine.
All right, so we are here now in front of our CNC routing table. This is a 4x8 machine with a 18,000 RPM spindle. And this is the machine we're going to use to cut the pockets in the foam, which is down here on the work surface. Now you can get much smaller versions of this machine that could fit in your home shop for several hundred or $1,000 or so. And many of your local shops and cabinet shops may have a machine like this. One of the Really great features of this machine is it has a very, very high power vacuum table. So powerful enough that it pulls a vacuum through a 3/4 inch piece of MDF, and that will provide enough vacuum that when it's on, this piece will not be able to move around on the table. It's very handy when you're cutting pieces of wood and you're not cutting all the way through the piece of wood. If you are cutting all the way through, you also need screw anchors or things around the table to hold the workpiece down. So what we're going to do is put a tool in the spindle, line that spindle up with our start point, our reference point, load our programs, and then get cutting. All right, well, we are done, and this is the result. I hope you guys enjoyed that video. I know it's a little long, but I hope you found it very educational and that you find some new hobbies in the area of CNC machining. If you enjoyed it, please like and subscribe. I'll put links to all this equipment and products down in the description. Thanks very much. Until next time, happy making.